Okay, so what we're talking about today, we're going to talk about the starting of a hypothesis test. So you guys read about this last night, hopefully, but every hypothesis test starts out with a null and an alternative hypothesis. And we're going to talk about how to write those and what they mean. We're not actually going to carry out the test until section 3. So today is just how are you going to form the test. Okay, I'm going to talk. I don't want you to write all of this down. You're going to write down the things that you think are important. Don't copy everything down. Okay, so here's the structure of a hypothesis test. You always have HO is called the null hypothesis. So N-U-L-L. It's called the null hypothesis. It's what we assume to be true. So for example, if you have to go to a court of law, it is assumed that you are not guilty, at least in our country. When you walk in, you're assumed to be not guilty. HA is called the alternative hypothesis. It's what we look for evidence for. So if you go into a court of law, they are going to assume that you are not guilty. And then they are going to look for evidence to the contrary. So they are going to look for evidence to prove that you are guilty. So here's how that's going to work. Again, you're assumed not guilty, and then they're going to look for evidence to prove that you are guilty. Okay, when this happens, so when there's enough evidence for HA, it's called rejecting the null. So you reject the null, and you instead believe the alternative. So I have enough evidence to believe that the defendant is guilty. Okay, sometimes you're going to find some evidence that the defendant is guilty, but you're not going to find very much. So there might be a little bit of evidence where you think, yeah, the person might have done this, but I'm not really convinced yet. In that case, you fail to reject the null. So I'm saying there's not enough evidence to believe the alternative. Now, this part in red is because it's really important. You never prove the null true. Ever. You never prove the null true. It's always you have evidence for the alternative or you don't have evidence for the alternative. Those are the only two cases. So in the case where you fail to reject the null, all you're saying is there's not enough evidence for the alternative. So there's not enough evidence to believe that the defendant is guilty. Okay, so again, this is what it looks like in a court of law. Either you're not guilty or you're guilty. They never call you innocent. Okay, in the case of not guilty, all that means is there's not enough evidence to prove that you are guilty. So for the null, you can either reject or fail to reject the null. You can never actually accept the null. So you never say that the null is true. You say I have evidence to believe that the alternative is true, or I don't have evidence to believe that the alternative is true. Those are the only two options. With me so far? Yes, this is extremely important. Yes? So basically the way a hypothesis test works is you're assuming that the null is true, and you're looking for evidence for the alternative. So basically you don't really care whether or not the null is true. All you care about is, do I have evidence for the alternative? If you have evidence for the alternative, then you're going to reject the null and say, I believe the alternative. If you don't have enough evidence for the alternative, you're going to fail to reject, and you're going to continue believing the null. But you're never going to say the null is true.
Okay, because we're never given like the entire population data to actually prove the null. In this
Right.
Okay.
Yeah. So here's how these things work. I don't know if you guys remember this from maybe 2 years ago. Do you remember that guy who went to Subway all the time and he figured out that their foot-long subs are only 11 inches long? You guys remember that? Okay, so anyway, I basically just told you the whole story. So he started measuring all the subs, and he found that each sub was about an inch too short. And so he went to Subway and he said, you guys have gypped me out of an inch for all the subs I've ever had over my entire lifetime, and he calculated you owe me, I don't know, $100 or something. Subway said, forget you, we're not paying you for that. And so he sued them and won a lot of money. I don't remember how much exactly. But in that case, they would do a hypothesis test. So if Subway claims we have foot-long subs, and you get a sub and you measure it and it's not a foot long, are you going to say, I definitely believe that they are lying to me based on your one sub? No, you might take a sample, right? So we think, the subs are supposed to be 12 inches, so we take a sample of size 10. And out of our sample of size 10, the average is 11.9 inches. Are we going to say that Subway's lying to us?
No.
Pretty close, right? Okay, what if we take a sample of size 10 and we get an average of 11? Do we think that they're lying to us?
Mm-hmm.
Maybe. That's kind of how a hypothesis test works. It gives us a way to figure out definitively what's the probability of that event happening. Because right now, if I tell you, I'm claiming 12 inches and 11 inches is what I got, some of you said, well, yeah, they're lying to us. And some of you said, no, they're not. So we need to have a way to definitively say, are they lying to us or not? Or what do we believe? And that's kind of what a hypothesis test does.
But so the hypothesis, like the HO in that would be like Subway is lying, saying that they're all 12 inches.
The null would be Subway is telling the truth. Because you want to assume that they're telling you the truth.
Oh, right. Oh.
So we're going to assume that the mean is
And you're gonna
12.
prove that.
And then we're going to look for evidence that they're lying. Okay. So out of this section, you should be able to write the null and the alternative. So that's what we're going to do next, and it's what you have on your page. So it says a certain TV station has been providing live coverage of a particularly sensational criminal trial. The station's program director wishes to know whether more than half the potential viewers prefer a return to regular daytime programming. A survey of randomly selected viewers is conducted. Let pi represent the true proportion of viewers who prefer regular daytime programming. What hypotheses should the program director test to answer the question of interest? Okay, so there's a few things about writing the null and the alternative that you need to know. So it says, what are the hypotheses? So we're going to have to write a null, and we're going to have to write an alternative. First thing that you need to know is they are always written in terms of a population parameter. So in other words, your hypothesis test is always going to be in terms of like pi, or mu, or sigma squared, always in terms of a population parameter. So in this case, it's telling us pi. So our null and our alternative are both going to be in terms of pi. The ones that we do this chapter are always going to be pi and mu. But I do want you to know that there are hypothesis tests that involve variance and standard deviation. We're just not going to do them. Okay, next thing that you need to know is the null is always a statement of equality. The alternative is always inequality. So it's going to be greater than, less than, or not equal to. And it's based on the context of the problem. Okay, remember that the null is what we assume to be true, and the alternative is what we're looking for evidence for. So the question says, the station's director wishes to know whether more than half the viewers prefer a return. So I want to know, is the proportion of people who prefer a return greater than 0.5? Is it more than half? Okay. Whatever number is in your alternative is also what goes in the null. So when I do this, I always write the alternative first. The null should be easy as long as you know what the alternative is. In these type of problems, I expect you to write the null and the alternative like this, and then to write me a sentence actually telling me what that means. Okay, so for the alternative, what does this mean to us? If the alternative is proven true, this tells us that the population proportion of viewers preferring a return to regular programming is at least 0.5. Oh, I guess not at least, I guess more than. Okay. Theoretically, if we prove the alternative true, what does that mean to us if we are the director of the station? What do you think we're going to do? We're going to return regular programming. So then we're going to say the station will return to regular programming. Okay, here's the part that's also a little bit confusing. The null and the alternative are going to be opposites. So what is the opposite of greater than? Less than or equal to. So although this is a statement of equality, it's understood to be less than or equal to. It's understood. You don't actually write it that way. I cannot stress that enough. You don't write it like this. That's what's understood to be there, but you don't actually write it like that. Now, the time that that comes into play is when you're writing the interpretation. So our null is written at pi is 0.5. We're really assuming that pi is 0.5 or less. So this means that the population proportion of viewers preferring a return to regular programming is at most 0.5. If I'm the director of this station, if the null is true, that means I will continue to show coverage of the trial. So the station will continue to show coverage of the trial. Okay, does this make sense? Katie?
Why do you need to have the second sentence hypothesis? Like, why do you need to tell them that you show coverage?
The second sentence is kind of the, like, so what? So why do we care that the people who prefer programming is that? Well, in reality, if this is the case, this is what's going to happen. We're going to keep showing the trial. So it kind of just tells the consequences of if this is true. Does that make sense?
Yeah, I'm just wondering because, like, considers like the hypothesis makes
I just like to add an extra. So what? I know it's a little worried. Sorry.
So for the second sentence, do we not have to write like if this is true? Should we just write like what will happen?
Okay, so here's what I need you to know as a recap. First of all, always population parameter. Second of all, the null is always a statement of equality, whereas the alternative is always a statement of inequality. And lastly, these numbers should always match. Kind of that's the basis of it. No questions? We're good? Can I raise? Yeah? Okay, so here is the next example. It says many older homes have electrical systems that use fuses rather than circuit breakers. A manufacturer of 40 amp fuses wants to make sure that the mean amperage at which its fuses burn out is in fact 40. If the mean amperage is lower than 40, customers will complain because the fuses require replacement too often. If the mean amperage is higher than 40, the manufacturer might be liable for damage to an electrical system as a result of fuse malfunction. To verify the mean amperage of the fuses, a sample of fuses is selected and tested. If a hypothesis test is performed using the resulting data, what null and alternative hypotheses would be of interest to the manufacturer? Okay, that was really wordy, but this is your problem to do. Before you start writing, here's what I would like you to do. First of all, I want you to choose a symbol. So am I going to use pi? Am I going to use p? Am I going to use mu, x bar, s, sigma, whatever? Define that variable. Write your null and your alternative in symbols. You don't need to write them in words yet. Just write them in symbols and then choose the correct symbol. Okay, so try that right now. Okay, right now, talk to the person next to you and see if you guys agree.
If it's less than 40 or greater than 40, then we live with the theory. Yeah, there's not 40. Either way, it's less
Yeah, the same thing, bug 40 there.
that makes sense too. I was go to I'll use. That's good because that's
Okay.
that just
I'm gonna stop you.
bipartisan.
First of all, what symbol did we use?
You
Mu, right? I mean, it tells you mean like multiple times. So mu is going to be the population mean amperage. Good news. You just learned the P in phantoms. P stands for parameter, like in Panic. Okay, guess it wasn't such good news. Okay, so you know your null has to be mu's equal to. I told you to write the alternative first. Is the alternative less than, greater than, or not equal to? Not equal to. We are interested in, is the amperage too high or too low? Okay, and then what number do I put in?
40.
40 is the only number that they give you. Okay, so writing an explanation. If the mean is equal to 40, if mu is equal to 40, what does that mean to us?
We're good.
Okay, I'm going to say, like,
The amperage is satisfactory.
okay, that works for me. Amperage is satisfactory. Okay, and if the mean is not equal to 40, okay, so we're going to say amperage is not satisfactory.
Unsatisfactory.
Okay, I'm a math teacher. Okay. Amperage is unsatisfactory. Is that better? The manufacturer So be liable for damages. So that's when the amperage is too high, or customers will complain. Okay, and that's the H part of phantoms. Questions? Sammy?
Does it have to be like who determines, like mu equals 40? Is there any give at all? Like if they measured some 40.01,
Yes.
there is give?
Yes.
Okay, how do we determine
We're not going to do that just yet.
okay.
But yes, there is give. So there's a formula that we're going to do in section 3 that's going to give us exactly like how much bump we have on either side. Olivia?
So in the first example, you know how like below the HO you wrote like it, like the opposite being like less than or equal to?
Uh-huh.
Should we still write that, or like on the AP test will that confuse the?
That's going to confuse the grader.
Okay, so
Just think about it in your head. Just kind of understand that that's what you really mean, but don't actually write it like that. Okay, questions? This is pretty much section 1. What I want to do for the last 7 minutes is give you a glimpse at where this is going. So we're going to do the example that's on page 9. It's the one about the radon level. Okay, so for this example, we want to know, are residents in a particular city safe from exposure to household radon gas? So the question is the mean radon level at or below city standards? So basically, are we safe or do we have room for worry? Now, first thing that I'm going to tell you is that I changed the numbers and I didn't change it on your notes, so you're going to have to change this. But the null is that mu is equal to 7. Not 6. So everywhere that it's a 6, you just need to change it to a 7. And then the alternative is that the mean is greater than 7. That also should be a 7, not a 6. So basically, city level is a 6. If you're at, 7. City level is a 7. If you are at a 7 or below, you're safe. Above a 7 is going to be dangerous. So with our null is mu is equal to 7. But based on the alternative, we know that this is really less than or equal to 7. So we are assuming that people are safe. We are assuming that there's compliance with the city standard. We are going to look for evidence to the alternative, or to the contrary. We're going to look for evidence that people are unsafe. So we take a sample. You guys have that sample on your page. What I want you to do right now is calculate the mean of that sample. Take out your calculator, put it in a list and calculate the mean. Okay, you should have gotten 7.7, right? Okay, so we are assuming that, or we are saying that a level of 7 is safe. If we get a level of 7.7 in our sample, do we think that we are above the city standard? Okay, it is above. But this goes to Sammy's question, is it significant enough? So is this far enough above 7 that we need to be worried? So that's where we need to calculate something. We can't just look at the number and guess. So this is kind of what we're talking about. Now remember how we talked about if the mean of a population is 7 and we take a sample, we're not necessarily going to get a sample mean of 7 just because of variability. There's going to be a whole bunch of different sample means. So we're saying 7 is our population mean, and we got a sample of 7.7. How likely is that? Is it rare enough for me to doubt my initial assumption? Or is it different from my initial assumption just because of variability? So what I want to do is I want to calculate the probability of obtaining this sample, assuming that 7 is the true mean. Now, in a continuous distribution, do we ever calculate the probability at one specific point? Like in a normal distribution, did I ever tell you calculate the probability that z equals exactly 1? No, you can't. No, we don't do that. So we need to change this into a range. Because our alternative is greater than 7, we are going to calculate the greater than probability. So we are going to calculate the probability of getting a sample mean that is greater than or equal to the one that we got, 7.7. This is going to involve changing into a z-score. So I have z is greater than 7.7 minus 7. That 7 comes from the null, divided by the standard deviation. Now, we have to remember that we are talking about samples. So, in the denominator is going to be the standard deviation of the sampling distribution. That's really important. So that's this one. You guys remember how to do that? You had to do this last chapter and in chapter 8. You probably know, you just can't remember, or you don't make the connection. That's this one. Standard deviation of the population over root n. So that numerator we're going to take from our sample. In our sample, we got a standard deviation of 2.98, and I'm going to divide by root 10 for 10 observations. Which ends up being 0.943. This is what we use in the denominator. Okay. Horrible place to stop, but the bell is going to ring.
Okay, so I've been changing the data in my list, and it kept giving me the same mean, and it did this to me like when I was taking the test too. I was like, wondering, why is this the mean? There's no number this high. So I don't know.
Okay, let me look at it. Guys, you have 3 homework problems due tomorrow. The first 3 on the reading notes are due tomorrow. Those are not questions like this. Those are questions like we did at the beginning of the class, write the null, write the alternative. So questions 3, 4, and 5 are due tomorrow. We are also going to do section 2 tomorrow. So I would like you to have the reading notes done also for section 2. Got it?